be on of that equipment, it will be accessible. So we only need the installation on the MCC panel. It doesn't matter the distance. Oh, yeah. We only monitor the current and voltage going to that equipment. So we do not. We are monitoring already submersible pumps for Petronas in Malaysia. Several submersible pumps. So yes, it can be monitored.
Okay.
And it's an offshore site.
Oke, mulai langsung banget. Oke, suaranya belum di-unmute. Assalamualaikum warahmatullahi wabarakatuh. Mohon maaf tadi ada kesalahan teknis, belum di-unmute. Selamat siang dan salam sejahtera untuk kita semua dan selamat menunaikan ibadah puasa bagi yang menjalankan. Selamat datang di acara webinar series kali ini yang akan mengusung tema Unique Sensorless Online Motor Condition Monitoring Technology for Rotating Equipment by Artesis Technology System yang akan dibawakan oleh Product Specialist PT TVP Product Specialist, Bapak 𝐔𝐬𝐽𝐿 Tanggang, dan sudah bergabung juga bersama kami Mr. 𝗏𝗏𝗏 selaku Business Development Manager dari Artesis Technology System. Nah, webinar kali ini akan dijalankan selama 2 jam ke depan, dan jika dalam proses webinar ada yang ingin ditanyakan bisa langsung mengetik pertanyaannya di kolom Q&A yang nanti akan dijawab pada sesi tanya jawab. Oke, langsung saja kita mulai acaranya. Pada Bapak 𝗏𝗏𝗏𝗏, dipersilakan.
Terima kasih, Dek Najel. Selamat siang, Bapak-Bapak dan Ibu-Ibu peserta webinar Tiara siang hari ini. Hari ini kita juga kedatangan salah satu prinsipal kami dari Artesis Technology System, Mr. Khalid Hussein. Hai, Mr. Khalid.
Yes, Rajiki, did you say something?
Please switch on your camera.
Okay. Okay, yeah. Sorry.
Thank you.
So, can you see me right now?
Yes.
So, hello, everyone.
Yes, great.
Yeah.
Thank you for joining us, Mr. Khalid.
You're welcome.
Okay. Before we start with you, I will present around 5 until 10 minutes about our background topic, and then I will switch to you after 5 minutes.
Okay.
I will share my present. Baik Bapak Ibu, sebelum ke Mr. Khalid, saya akan memaparkan latar belakang mengenai topik kita hari ini, yang merupakan topik yang saya kira sangat penting di plan kita masing-masing, karena kita semuanya punya motor di lapangan atau di plan masing-masing. Nah, pertanyaannya adalah yang pertama yang perlu kita tanyakan apakah kita atau mengapa kita membutuhkan motor monitoring atau motor condition monitoring? Itu pertanyaan yang sangat penting, dan nanti kita akan jawab juga selama berdiskusi di siang hari ini. Saya akan mulai dengan life cycle strategi. Saya yakin Bapak Ibu semuanya sudah sangat familiar dengan life cycle strategi, baik dalam hal mengelola motor atau mengelola equipment kritikal lainnya, baik generator, kompresor, turbin, pompa, dan lain-lain. Di sini saya membuka salah satu software yang didevelop oleh kami, PT TVP Product Pratama, yaitu software Bolen, atau kepanjangannya Baseline for Overall Life Cycle Management. Nah, saya akan mencoba menarik garis yang akan menghubungkan kita dengan topik mengenai motor condition monitoring pada siang hari ini. Nah, kita tahu dalam life cycle strategi kita tujuannya yaitu mengelola critical equipment kita, di mana pada semua critical equipment kita akan menemukan adanya function failure yang bisa saja muncul, apakah failure yang bersifat bisa dikelola dengan PDM atau PM atau task kategori lainnya. Nah, di setiap critical equipment, ini contohnya motor semuanya mempunyai failure mode, failure effect, maupun failure cause. Nah, dalam hal topik hari ini, saya akan lebih spesifik terkait dengan failure cause atau failure mode yang bisa kita monitor dengan motor condition monitoring atau teknologi untuk mengelola motor, seperti itu. Nah, saya yakin Bapak Ibu sudah sangat familiar dengan ini, dan dalam keseharian juga life cycle strategi dalam hal mengelola semua failure, baik di motor ataupun equipment lainnya, kita akan mencoba melakukan pengelolaan setiap failure cause yang muncul. Tujuannya supaya failure tersebut bisa kita monitor, kita deteksi lebih dini, kemudian kita kelola supaya tidak terjadi yang namanya failure. Nah, untuk topik khusus hari ini, kita bisa melihat contoh di sini ada motor, kemudian memiliki failure cause deformation ataupun edging yang bisa kita kelola dengan task kategori PDM atau predictive maintenance, dengan task motor current analysis ataupun motor signature current analysis ataupun motor monitoring lainnya. Nah, di software ini kita juga bisa mengelola ya, apakah failure tersebut sudah kita kelola atau tidak. Aktif di sini artinya kita sudah mengelola, tidak aktif artinya kita belum mengelola dan membiarkan failure ini muncul dan bisa menyebabkan adanya failure. Nah, pertanyaan tadi, mengapa kita membutuhkan motor condition monitoring? Kalau Bapak-Bapak lihat, dan Ibu juga yang hadir, semua task di sini merupakan task yang dibutuhkan untuk mengelola motor secara keseluruhan, supaya kita mengetahui kondisi dari motor ini, atau yang kita namakan dengan asset wellness. Nah, di sini Bapak-Bapak bisa mengelola secara keseluruhan, baik tasnya maupun frekuensi, kemudian apakah failure tersebut sudah dikelola atau belum. Nah, dari situ kita akan dapat melihat asset wellness dari baik motor ataupun yang lainnya, maupun generator, turbin, kompresor, pompa. Nah, di sini kita bisa melihat kondisi dari asset wellness ataupun teknologi status dari critical element tersebut. Kalau saya ambil contoh di sini, dalam hal cooling tower, Bapak bisa melihat cooling tower yang statusnya apakah hijau, yang berarti kondisinya masih baik, kemudian kuning, ada problem, sudah mulai muncul adanya failure, kemudian ataupun merah, yang berarti danger dan butuh dilakukan mitigasi secepatnya. Kemudian dari teknologi status, kita juga bisa melihat apakah cooling tower tersebut sudah kita monitor dengan motor monitoring atau belum, yang berkaitan dengan tentunya dengan motor condition monitoring ya. Kalau kita memang menggunakan teknologi lain untuk memonitor seperti vibrasi, oil untuk failure tertentu, nah itu juga akan ditampilkan statusnya apakah hijau, kuning, maupun merah. Nah, dari situ nanti dari semua teknologi status akan disimpulkan asset wellness atau status kesehatan dari mesin tersebut, dari motor tersebut, apakah masih baik atau perlu dilakukan mitigasi yang secepatnya. Oke, nah itu pengantar dari saya mengenai latar belakang topik siang hari ini. Semoga ada gambaran ya kenapa kita membutuhkan motor condition monitoring. Oke, selanjutnya akan saya serahkan ke Mr. Khalid. Mr. Khalid?
Yes, Rojeki.
Your time, please.
Okay, thank you very much, and welcome everyone. Let me start by sharing my screen. Okay. So today we will be talking. Can everyone see my screen right now?
Yes.
Okay.
That's great.
Okay, so today we will be talking about Artesis. Artesis is a manufacturer of condition monitoring tools without sensors. So we only need the current and voltage signals coming from the
Mr.
MCC.
Khalid,
yes?
Will you please switch on your camera?
Okay, one second. Okay, yep. Okay. So as I was saying, we are using the current and voltage signals to coming from the MCC panel to monitor your equipments for mechanical, electrical, and process faults in one system. A brief background about Artesis. Artesis was founded in 1999 by its founder, Ahmed Diyar. He was working at NASA for 11 years, and during his researches with NASA, he developed a unique technology to detect faults in space shuttle engines, helicopter engines, and gas turbines. Later on, he decided to commercialize this technology and established Artesis. So After a few years later, after Artesis was established, we have developed a very huge database which we utilize to detect existing fault inside equipment. So the first product of Artesis was launched in 2006, around 6 years after Artesis was established. A few years later, this technology attracted very huge companies, and one of them was General Electric, which decided to become a shareholder of Artesis. So now GE is owning 20% of Artesis shareholders. Our headquarters is located in Turkey. We have our own office in USA and our sales distributed partners all around the world, including PT Tiara in Indonesia. So as you know, for decades, vibration analysis was a dominant in the market, and recently personals and people's companies started to get interested in the digitalization, Industry 4.0, where everything will be automatic and simpler to use. Not like for decades it was they were using to use vibration analysis for everything was done manually. They needed to go to access the equipment itself, install sensors on the equipment, collecting data from those sensors, analyzing the data, and coming out to the report. So it was taking time and effort from them. So Artesis' target is to simplify the maintenance planning, and it has done this through these features. So first of all, it provides effortless condition monitoring. So the system is simple and easy to use to anyone. No need for the expertise in how to use the software. It is almost 90% automated. No need for advanced knowledge in order to analyze the report, and it gives actionable information for maintenance scheduling. As you can see here, this is a snap from Artesis software where different kind of faults is represented in the bars showing the severity of the faults. Also with Artesis, you will get a comprehensive fault coverage covering mechanical, electrical, and process fault in one system, and not only detecting the faults in the motor side, but also on the driven equipment side and the drivetrain or the transmission line between them. So it gives you a general overview about your equipment condition. And the accuracy of Artesis system is up to 90% because it already have a pre-trained database which we use to detect existing fault inside your equipment. So it's continuously monitoring equipment, learning about your equipment condition, and comparing it to the database that we have, where we compare your equipment to the nearest model from that database to detect existing fault into the system. So that's why we need a very short learning period. In only 12 days, we can start monitoring your equipments, unless like other systems where you will need years to the system to learn on your equipment and to give you accurate results. Besides detecting mechanical, electrical, and the process faults, also our system works like a power monitoring device. So you can see the effect, you can see the energy consumption of your equipment on a daily, weekly, quarterly, yearly information. And also you can see the effect of the faults on energy efficiency. So this information will help you plan maintenance accordingly. When you know how much energy you are losing because of the fault that you have, then you will have a better view when to plan maintenance accordingly. So this is a snap from the software showing an example on how the system detects the effect of the faults that you have, existing fault inside your equipment on your energy consumption. And finally, integration to third-party HMIs like SCADA system. So you can integrate it using OPCDA to your SCADA system, or DCS system can be integrated. So basically, Artesis have two kind of products. One is the EMCM and the other one, which is the AMT Pro. The EMCM is a 24/7 days a week continuous monitoring device, which we will be talking about today. And with this device, you will be able to monitor your equipment from the MCC panel without needing to install any sensor on your equipment and online. So before diving into the product, let me just go through the technology and what is behind of Artesis technology. Our technology is a patented model-based technology. We call it model-based fault detection. We take the voltage as an input and the current as an output, and we use the motor itself as a transducer or a sensor. So in an ideal condition, this is the concept of the technology, in an ideal condition, the sinusoidal voltage signal supplied to the motor at the output, on the current side, it should be exactly similar to the input. If the motor was operating in an ideal condition, there is zero vibration there. But in reality, this is not applicable because of the normal behavior of the equipment. There will be some distortions on the current waveform. So as you can see here, this is a 50 Hertz supplied voltage signal going into the motor at the output. Because of the normal behavior, some vibrations or some distortions will cause some distortions and harmonics to show themselves on the second and third harmonics. So our technology, the EMCM, will be installed in parallel with the actual motor. And during the learning period, which is 12 days, it will create a digital twin about this motor. So it will learn how this equipment is operating and create a model based on that, and then start to estimate based on the model that it has learned how this equipment should be operating. So the supplied voltage will go in both the motor, the actual physical asset of yours, and our system, which is the EMCM. And later on, after the learning period is done, the EMCM will start estimating the output. So the EMCM will take the difference between the actual current coming from the motor and the estimated output from the digital twin. So if there is no fault, the result, we will extract the actual current from the estimated output, and the result will be zero. Let's say that you have a mechanical fault on the motor side or the driven equipment side. So this mechanical fault will cause some harmonics to show themselves on the, or distortions to show themselves on the current waveform. As you can see here, some extra harmonics started to show themselves, so due to some kind of mechanical fault. So since our model, the EMCM, knows how this equipment should be operating, it will just estimate the ideal condition of this motor. And we will extract this waveform from this, and this extra harmonics here will be amplified and shown here. And based on how far the peaks are from the line frequency, we can know what kind of mechanical fault is going there. This, we call it power spectral density. Vibration, people knows it as spectrum analysis. So this is how we detect mechanical issues. Another benefit of Artesis is to distinguish between mechanical and electrical fault. Since we are monitoring the current and voltage as well, in case there is any electrical issue on the supply side, power distortions, some loose wire situation, or some faulty VFD. So it will cause the voltage to come with some extra harmonics or distortions on the waveform here. So these distortions will be supplied to both the motor and the digital twin. So they will be added on top of the actual current here and the estimated output from this digital twin. So when we take the difference between them, the result will be zero. So our EMCM will know that this harmonics here, since the result is zero, they are not coming from the motor. So this is not a mechanical fault, but it's a purely external electrical fault. And it will automatically tell you to check this and this to fix the faults. So this is how Artesis system distinguish between mechanical and electrical faults. Since we are monitoring the voltage, we can detect voltage variations like harmonic distortions, voltage fluctuations, voltage balance, and etc. And on the current side, the current variations can help us detect process faults, process changes in the equipment, like the speed, the load. If anything changes, we will detect that. Cavitation issues, plug filter screens, all these kind of faults, process faults will be detected. So the fundamental behind this technology is simply relying on the air gap that is between the rotor and stator. In an ideal condition, this rotor and stator is a uniform distance between each other. So whenever there is a mechanical issue on the equipment, on the motor itself, or the driven equipment, or the drivetrain itself, it will cause the rotor to shift from its place. So when the rotor shifts from its place, it will start making it will affect on this air gap and the magnetic flux within it, which will cause the motor consume more current. So since we are monitoring the current, we will know what kind of mechanical fault is going on with the equipment. The clustering algorithm, this is also one benefit of Artesis. We learn different models for the equipment, so not only one model, and it helps to monitor equipments driven by VFD, which are operating in a varying speeds and loads. So this is how it works. When you first install the EMCM, it will start learning the models of your equipment, the processes that your equipment is operating at. So let's say in the first day, your equipment is operating at a specific speed and specific load. So we will create a cluster for that and learn a model of this condition and cluster it. Second day, there is a new condition. So we will create a cluster for that new condition as well, and so on. So during the 12th day, it will just keep detecting all the different speeds and loads that your equipment is operating at. And at the end of the 12 days, it will start comparing your equipment condition, initial condition, to the nearest model that it have learned here. And if there is any change in the speed or the load, it will notify you. So this is how we detect process faults. I can give you an example so you can understand more. For a cooling tower fan, for example, you have installed the EMCM in summer. So the EMCM during 12 days, it will learn all the different speeds and loads that this fan is operating at. At the end of the 12th day, it will start monitoring. So a few months later, a new condition will occur. So because winter will come, so the weather will change and the fan will start operating at different speeds and different loads. So the EMCM will detect that change and notify you that there is a load change. Is it a fault or is it a new condition? So it is your turn to confirm, to check whether it is a process fault, something that changed that you didn't want it to change, or it is a normal change due to weather. So if it is normal, then you can just update the system and it will add that new condition to the learned conditions and keep monitoring. So it is continuously learning about your equipment processes and notifying you if there is any changes in the process of your equipment. The installation of the EMCM, once you install it, it will take 3 days as a learning period. So during these 3 days, the EMCM will create models about your equipment, all the different models that it can detect, it will create them. And after the 3 days, it will take another 7 days as an improvement. And during these 7 days, it will try to detect if there is any other condition or that your equipment is operating at that wasn't detected in the first 3 days. And later on, at the end of those 10 days, it will start monitoring. So this is how EMCM learns. Now, the EMCM is consisting of 2 parts. One is the EMCM device itself, which is a DIN-rail mountable device. It is mounted inside your MCC panel, and the HMI screen which comes with it. And this HMI screen is installed on top of your MCC panel, where you can see the electrical parameters of your equipment on it. So it's working like a power meter. With the EMCM, you will have a lot of features. So we will go one by one on the features that this EMCM offers. So first of all, the traffic light warning system. So with from here, you can see all your equipments that are monitored with EMCMs, and you can see the condition of your equipment from here by looking at the colors. So different colors represent the condition of your equipment. Yellow means an electrical or a process fault. Red means a mechanical fault. Green means the equipment is okay, and gray, which means the equipment is not operating. And we have two versions of this software. One is the online cloud software, and the other one, which is the local software. So you are free to choose which one to use in your facility. And from here, once you understand which equipment is faulty, this traffic light warning system will give you the capability, or the EMCM will give you the capability to focus on the faulty equipment instead of going and checking all the equipments to find out which one is faulty and then plan maintenance. So it will save your maintenance team time, and they can focus on the faulty equipment. So now, once you detect the faulty equipment here, as you can see here, this is, for example, this equipment have a mechanical fault. So by clicking on it, you will be able to see the automated fault diagnosis. So we do not only detect the fault equipment, but also we tell you what is going on with your equipment. We do the analysis automatically for you, and it is represented as shown here. This is the automated bar graph, and we have divided it to several faults: loose foundation components, unbalanced misalignment, transmission element driven equipment fault, bearing fault, rotor fault, stator fault, internal electrical fault, external electrical fault, and other fault. So external electrical fault means any fault coming from the supply side, not from the motor. And internal electrical fault, which means any electrical issue inside the motor itself. And other fault is any kind of fault that is not classified in this bars here. Now, in this bar graph here, you can see that for each fault, there is 2 bars. You might ask yourself why. Now, since the EMCM is continuously monitoring the equipment condition, the light blue bar is the first condition that the EMCM detected in your equipment. So you might, if the equipment was faulty from the beginning, there is a fault inside of it, and you install the EMCM. Will the EMCM be able to detect that fault? Actually, yes. Because of the database that I have mentioned in the beginning of my presentation, we have created a very huge database, millions of motors, and using that database, once we learn about your equipment, once you install the EMCM will automatically go to that database and detect the nearest model to your equipment and compare it to it. So if your equipment have some kind of fault, it will be able to detect it, and it will be represented as this light blue bar. Now, the dark blue bar is the most recent reading coming from your equipment. So you can understand how the fault is developing through time. So that's also will help you plan maintenance. So if the fault is stable, then you can choose to wait. And once you see that it started to increase, then that's mean the fault is going up and you need to act immediately. Now, the severity of the fault is represented here. As you can see, the green dotted line is the accepted threshold of this equipment, the behavior of the equipment. The yellow color means a caution zone, which means that you have from 3 to 6 months time to plan maintenance accordingly. And the red, which means that you need to plan maintenance the soonest within less than 3 months. So we detect with our technology, we detect faults up to 6 to 9 months earlier before the faults start going severe. So you will have time to plan maintenance and avoid any sudden crash in your system. And you can see here the electrical parameters of the equipment. So if there is any electrical parameters going out of range, which is the threshold set automatically based on global standards, then automatically you will see the system will start giving you notification that you have this, and corrective actions and work order will be given accordingly, what you need to do to fix those faults. Also, the EMCM works like a power meter, so you can see the energy consumption, daily usage, how much running hours your equipment is running, and you can see also the effect of the faults on the energy consumption. As you can see here, for instance, you have two faults, the bearing fault and stator fault, which are causing the system to lose around 55,000 kilowatt hour per year. And this, the software will automatically give you a suggestion that by removing these faults, you will save up to this percentage of energy. So far I have covered the automated part in our software. Now we come to advanced users who want to know the root cause of the fault. We have the spectrum analysis, which is, I think, yep, it was mixed here. Sorry, I think the slides just up. Spectrum, oh yeah, yeah. Okay, this is the spectrum analysis, the cloud version and the trend analysis as well. And the local software, the Microsoft-based software. So this is the spectrum, and this is the trend analysis. In this spectrum here, you can see that we have three waveforms: the blue, the green, and the red. Each one is representing something. So the blue one is the actual equipment behavior. So once you install the EMCM, it will learn the model of your equipment, and it is the blue waveform. The green waveform is the nearest model from our database. So this is the acceptable behavior of the equipment. And the red one is the threshold set, the alarm threshold set by the software. So if the blue waveform starts exceeding the green waveform, then this is representing a specific kind of fault. And we have divided this spectrum to 12 bands. At each band, a specific kind of fault is detected. So it is very simple to use, as we have divided like this. So first band, loose foundation; second band, it's unbalanced misalignment; third band is transmission, and so on. So it's very simple to do the analysis by yourself. And you have the trend analysis as well, where if you see that in the bar graph, it is showing you some kind of fault, or whatever the fault that you have there, you can come to the trend and see the history of this fault. So for instance, if you click on the transmission and see, you want to check when the fault started developing and how fast it is developing, you just click here, choose from what date to what date you want to see, and plot it. And you will be able to see the behavior of this fault through time. So it will help you to detect when the fault started developing and how fast it is developing, which will help you in your maintenance planning. Oh, sorry, this is just mixed together, these two slides. Yeah. So the general system overview looks like this. So as you can see, each equipment will have one EMCM into the MCC panel, and all the EMCMs will go into the server, so where we will install the software. And from there, you can integrate it to your third-party software like SCADA system or OPS, so your system. And you can also integrate it to the cloud, so you can see it both locally and also online. This is how the cloud software looks like, the online software. So this is the dashboard, and which is looking a little bit more modern than the local software, but same features are in both softwares. Now, in case you have an offshore site that you want to monitor, the EMCM will be installed in the MCC panel on your offshore site, and you can just assign a 4G LTE router with a SIM card internet to give it access to the internet, and it will automatically connect with the cloud, where you can monitor your equipments online from any device, anytime. This is the communication, the local communication. So each equipment will have EMCM, and the EMCM using Ethernet TCP/IP cable will be connected to the switch in your local network. And from the local network, you will assign a PC or a local server where you will install the software to analyze the data generated by the EMCMs and show it, monitor your equipments. And also simultaneously, you can also integrate it to the cloud and see the results online from any device. Now, how does the EMCM works? It's simply using the current and voltage signals from the electrical supply, three-phase supply, to detect mechanical, electrical, and process faults. Software will need to be installed on your server, so you need to assign it a server and to install the software, and you will be able to monitor your equipment. It is applicable for three-phase AC fixed and variables speed motors and generators. So it doesn't matter if it is driven by DOL system, VFD system, we can monitor all of them as long as they are three-phase AC. There is no limitation for voltage or current, so we can monitor all sizes of equipments. The only limitation is the speed. So if the speed is less than 300 RPM, we will not be able to give you accurate results. So the accuracy will go less and less as low it goes with the speed. Same thing with the load. So if the load is less than 60%, the accuracy will get lower. We will still be able to detect faults, but it will not be as accurate when the equipment is operating at a load of more than 60%. So once you install the EMCM, the software will generate reports for you with showing you the faults and the corrective actions and work order based on that. And so this is the fault types and alarms. So normal, which means the equipment is okay. Watch line, electrical fault. Watch load, which means the load is changing. So is there something going with the process? Check it. Examine one, which is the first alarm for mechanical issues. Examine two, which is the second alarm, which is more severe. Now the installation into the MCC panel, it's a 10 to 15 minutes hardware installation. It's simple. The EMCM is installed. It's a dim-rail mountable device, so it's mounted inside the MCC. And it's a 10 by 6 centimeter the device, so it's small. It will not take space in your panel. And as you can see here, you have 3 voltage connection up to 690 volt. You can do direct connection to the voltage line, to the supply phases. And if it is more than 690 volt, then you need to connect it to the secondary side of the existing potential transformer or voltage transformer. And you have, with the EMCM, we will provide you with a suitable split car current transformer. So the split for current reading. So this split car current transformer, they are non-intrusive. You do not need to do any cutting on the cables. You just tap them around the cable and connect them to the EMCM. And a single phase AC or DC supply power will be provided to the EMCM to power it up. And using this Ethernet port, you just connect it to your network. So it's a 10 to 15 minute hardware installation, very simple and easy to install into your panel. So since it is installed in the panel, you will not need to access the motor at all, which makes it the perfect solution to monitor, or the only viable solution to monitor submersible pumps, cooling tower fans, borehole pumps, cryogenic pumps, and ATEX zones. Yep. Now, so we will go through some case studies about the technology. So this is, for example, case in Nissan in the United States in the automotive sector. So a gearbox for a conveyor, a gearbox fault was detected. So you can see here in the bar graph, a transmission element driven equipment fault has increased. It is going up and it is in the caution zone. And in the spectrum, you can confirm it by looking at these 2 peaks, which are exceeding the green waveform and confirming the transmission element fault. So this fault was detected and they have confirmed it with vibration, continuous vibration monitoring. So as you can see here, the 20H1GB1 peak scale shows that it has passed the warning threshold. So it has passed the threshold and confirming the gearbox fault. So this is one case. This is meanwhile in the United States. As you can see, the software here, external electrical fault, the dark blue bar started to increase and it is showing itself in the caution zone. And the light blue bar, you see that it already had some issue, but not very severe. And in the dark, then it started to increase through time. So when it increased, external electrical fault, as I mentioned, means any electrical issue in the supply side, whether it is a loose wire cable, contactor problem, loose screw. So the software will tell you to check all this to find out the reason for this increase. So when they went and checked on their supply side, they found that a loose wire. So they fixed it and everything came back normal. So when they came to the trend analysis, they clicked on external electrical fault, choose from what they wanted to see. So you can see the behavior of the fault. So the threshold is set automatically by the software. So everything was normal till 5 March, where the trend started increasing. And you can see here, it exceeded the threshold and started to show itself high. So when they planned the maintenance, the trend went back again below the threshold. So this is one case for electrical connection looseness. Now, bearing failure here. As you can see here, it's a fan for a glass manufacturing case here. And so as you can see, the trend was normal for the bearing failure and everything was normal. As you can see here, slowly the trend started to increase. So examine 1 notification was sent to the customer, and then the team, few days later, they have confirmed that they heard the noises and confirmed the vibration, the bearing problem, which caused this increase in the trend. And after that, they planned the maintenance accordingly. This is a belt transmission element fault. So in a fan, and you can see here that the transmission element notification, the trend started to increase, and the system started to give examine 1 notification for them, and outside, and the maintenance team was informed. So on 19 October 2015, the belt tension was adjusted. So they detected a tension issue in the belts, which was causing the transmission element trend to increase. So when they fixed it, the trend went back below the thresholds. Now, winding failure in a fan here, as you can see, the trend from the beginning was giving a notification. So you can see here, this is the threshold set by the system. So the system was already giving internal electrical issue notification. So the internal electrical failure parameter here was already above the threshold. And for a while, as you can see, 19 November, a sudden increase happened in the trend, and that was due to the motor burned. So the equipment was burned. So they confirmed it, and when they went back to the trend, they saw that the system was from the beginning giving them examine 1 for a long period of time, but they didn't act upon it, and the equipment burned upon that. So as you can see here, it was okay, and then in 19 November, it just jumped because the equipment burned. And the same equipment, when they checked the active power after they did the maintenance for that equipment. So this is the current, the active power before the stator failure. As you can see here, it was below the thresholds. And after they did the winding, the current, the active power has increased also. Same thing with the current parameter of the equipment. So the current parameter also increased. So the winding, there was a problem in their winding, and when they checked again, they found that the winding was not successful. So they did it again, and then the current value decreased. Also, the active power went down. So this is some case study, and belt breakage problem here in the air handling unit. So you can see the trend was below here. So this is transmission element, the trend, and you can see the trend was below the threshold, and in 23 January it started increasing and going up. So and the software, when it starts exceed the threshold, it will automatically give email notification to the client showing that there is a fault And when they went and checked in 23 January, so you can see 23 January here. Yeah. So on 31 January, 23 January, the trend started to increase. And in 31 January, they went and checked the system, and they found that the belt, that drive the aspirator has been broken, and the other two are loose. So they went after the planned the maintenance, the trend went back normal. So this is all the case studies that I have today. And I think I am done with the EMCM right now. So if you have any question, I think, do we still have time? Or Rojaki?
Yeah, thank you, Khalid.
Yeah, you're welcome.
So we have some good questions here. And I will start with question about the automatic diagnostic fault. Khalid.
Yes.
Can you show me the bar graph again?
Of course. Let me. Oh, just 1 second. Let me show you the software in live. It will be better. Okay.
Yes.
So, yeah. Let me just 1 second.
Maybe you can also zoom in the bar graph.
Yeah. I will just show open the software and show you the bar graph. 1 second. Okay. Okay. So this is 1 second. Let's connect. Yeah. Now this is just showing you the case. Yeah. This is the bar graph.
Yes.
Your question was?
The question is regarding to mechanical fault. So if we find, or like this case, unbalance or misalignment is high, right?
Yes.
And then, do we need to confirm with the vibration analyzer or something?
Actually, this is up to the customer. Our system, when we confirm with vibration, it's just to create a case study, but our technology is accurate up to 90%, so it can be relied on for that. But yeah, it's not necessary to use vibration to use that. But I can give you an example when you need to use vibration, like in the bearing issues, for example. If the system gives you that you have a bearing fault, you want to know which bearing is the faulty, then you need to come to the PSD, to the spectrum that we have here. So in this spectrum here, we have a bearing section, and you need to enter the bearing parameters of your equipment and plot them to confirm which bearing is the faulty. Is it on the driven equipment side or the motor side? But now let's say that the bearings on both the motor and the driven equipment are typical. They are the same. So then only you need to use the vibration analysis to confirm that. So yeah.
Yeah, okay. Thank you.
Okay.
And then the next question is related to the spectrum graphic, Khalid.
Yes.
You just saw, yeah.
Yes.
Question from Mas Dimas. From this spectrum graphic, what data signal and with what unit is the amplitude in the Y?
Yeah. Yes. Actually, this is the residual current waveform. Okay, and the as you can see here, this is the frequency of the peaks, and the amplitude of these peaks, the severity, is based on a standard deviation based on our database. Now, I told you This is based on, we decide whether there is a fault or not based on the ideal condition that we have in our database, which is the green waveform. So if the peaks, the normal behavior of the equipment start exceeding this green waveform, then that's mean based on the ideal condition of that equipment from our database, we can know what is the severity of this fault. So it's, yeah, it's done like this. Standard deviation.
What is the unit? The standard
I told you this is not, there is no unit. It's an amplitude standard deviation, something related to our technology, to the database that we have.
Oh, okay.
Yes. So.
Okay. Okay. Thank you. Thank you, Khalid. And then next question is from Pak Hendro. Do we have to shut down the unit for installation?
Actually, for safety, yes, safety procedure, yes, you need to shut down the motor, do the installation. So it's a one-time installation. You do not need to do it every time, but it's up to you, because we sometimes some of our clients, they do not shut down the motor. They can do the connection while the motor is running. So it's because we do not deal with high voltages up to 690 volt, and after 690 volt, we just connect to the secondary side of the existing PT and CT. So, but we recommend, yes, to shut down the motor to do the installation.
Okay, thank you, Khalid. And then next question is for the cloud. Is it for data storage only, or we do the analysis in the also using the cloud?
Okay, let me show you the cloud software so you can see. Let me access it here. Second. The cloud is actually, we have two options for the cloud. So if the client, let me share my screen here. Okay. Okay. So can you see my screen?
Yes.
Yeah. This is the cloud. It's online. Now the data here shown in this cloud is stored on our cloud server. Okay.
Yeah.
You have the option to, if you have your own cloud server, this software can be installed on your cloud cloud server. So the data can be stored on your server, on ours. It doesn't matter. It's up to you. You can see from here the general condition of the equipments, how many equipment is running, how many is not, which one is faulty. You can see the status summary. So many features is coming with this software. You can see the detailed info, the report. So all the analysis can be done on this cloud software. You can see the report similar to the local software. You can see the PSD as well, the spectrum analysis. So everything can be done online on this cloud. You can see the electrical parameters with their thresholds. So yes, it is available. You can do the analysis there.
Great, thank you, Khalid.
Welcome.
And then we have some good question. Another good question from Pak Willis. Yeah. For the machine learning, do the machine learning develop to detect failure and suitable for every equipment that have a different brand?
Yes. Actually, this is a machine learning technology. So it's it's learning all kind of equipment. It doesn't matter. We do not, it is not important for us. There is no calibration needed for this device. So the only parameters that we need is the nameplate value. The model of the equipment is not important for us. Once you enter the nameplate value and we learn about the model of this equipment, how it is behaving, based on that, we detect the nearest model from the database. So the model of the equipment is not important for us. Yeah.
Also for the related to the age, is it a brand new or old? No matter.
I told you that if even faulty equipment, it can be detected. So the faults can be detected, as you can see here in the bar graph. So the light blue is the first reading that the EMCM will detect. So if your equipment is old, have some kind of fault, it will be shown in this light blue bar here.
Okay. Okay, great. And our two last question, yeah.
Yes.
Do we need to calibrate the system, the technology?
This is a pre-trained technology, so it already have a very huge database inside of it. So no need to do any calibration to this device. What you need to, what the software will ask you is only the nameplate values of the equipment. That's all what we need, and then it will automatically start a learning process by itself, create models for that equipment automatically, and then show you the report automatically for you. So it is almost 90% automatic. The only manual part is the PSD. If you want, even the PSD is automated. As you can see by clicking here on the bands, you can see what kind of fault is going on with in this band. So if you see a peak inside the field, this is, for example, transmission element, and so on. Yeah.
Okay, thank you, Khalid.
You're welcome.
And then, wow, we got another two questions.
Yes.
From Pak Andi, how equipment can protect big data store in the event of the natural disaster?
Can you repeat again, please, the question?
How the equipment, I think Pak Andi means that how our store data.
The data stored.
Yeah.
Yes, yes.
And in the event of the natural disaster happen.
Yes.
How equipment protects the data. I mean, I think he means it's the system, yeah.
Yes,
the data that already stored.
Yeah, I understand the question. Actually, the data that we store, no one can understand it, but our software. So if someone else get a hand on that data, they will not be able to understand anything. What is those data means? And also the data can be stored on it will be stored on a server. So you can assign a server in a separate place, or if you use our software, our server, data will be stored on our server. You can also create a copy of the database and store it somewhere else. So it's we are flexible on that side. You can store the data or everywhere. Yeah.
Okay, and then related to the I think the cloud, yeah, the technology cloud. Is it in case of the safety of data and then the confidential of data, is it guaranteed by this system?
Yes, the cloud server that we are using is Amazon Cloud. So if you choose to not use our cloud server, if you have your own cloud server, then this software will be provided to you. We do not charge on the softwares. It's like other vendors or other companies will ask you, will keep you connected to them. You need to pay on a continuously basis. But with us, we will give you the software free of charge. We do not charge on it. You install it on your cloud or on your, you can choose this one or the local software and install it on your premises, and you don't need, like, it's not connecting you to us every time you want to make a payment or something. Yes.
Okay, last question for now, Khalid. Our topic is about motor condition monitoring, but based on our webinar today, that this technology not only to monitor motor, right? Also,
yes, generators.
To monitor generator, pump, and others. Please, can you describe for us?
Yes, actually, our technology is to monitor all kind of motors and generators. As long as they are three-phase AC. So the fans, the pumps, the conveyors, compressors, mixers, all kind of driven equipment, we can monitor them and detect fault of them. And you will be notified. As I shown in the cases that I have shown to you, we can detect the faults even in the driven equipment side, whether it is a conveyor, a transmission line, gearbox issue, a fan issue. All this can be detected with our software. So yes, it is monitoring the whole equipment, not only a part of the equipment. So as mentioned here, covering the mechanical, electrical, and process fault in one system. So it's giving you a general overview about your equipment condition. Yes. So I think
great. Khalid, I think for now, that's all the questions.
Yep.
You have another to present?
I think I lost. Okay, Rajaki,
yes.
Thank you. I think I lost connection. I didn't hear. Did you say anything?
Oh yeah, another question. Khalid, there are two questions.
Yeah.
Oh, one question.
Yes.
Is there any limitation of distance, for instance, for oil submersible pump?
No, because the MCC panel will be on of that equipment. It will be accessible. So we only need the installation on the MCC panel. It doesn't matter the distance. Oh, we only monitor the current and voltage going to that equipment. So we do not. We are monitoring already submersible pumps for Petronas in Malaysia. Several submersible pumps. So yes, it can be monitored.
Okay.
And it's an offshore site.
Okay. Thank you, Khalid. That's all our questions.
Okay, great.
And do you have anything to say?
I think I would like to thank everyone for joining and for listening to this introduction. Yes, thank you very much, Rajaki, for arranging this webinar. So
thank you very much, Khalid.
That's all what I want to add.
Joining us today. That's a great presentation and great discussion for us today. And see you next time.
Okay, see you. Thank you very much.
Thank you, Khalid. Oke, demikian tadi Bapak Ibu webinar kita bersama Mr. Khalid dari Artesis Teknologi Sistem. Semoga bermanfaat. Sampai ketemu dengan webinar Tiara selanjutnya. Akhir kata saya sampaikan, habis gelap, terbitlah terang. Terima kasih.